the recording. Okay. And we can start. Any question at the beginning? Yes? Yeah, sure. At the end of the lesson. So, what we are going to address in this module, essentially what we will see is a possible solution for a lifelong digital identity to interact with the people, organizations, objects over the internet to build trust interaction with anyone without the need of a central authority to generate our own identity, to prove our identity for any authentication purpose, for example, and to verify this identity. This is, let's say, a general objective. One possible model that implement such a kind of objectives is for sure the self-sovereign identity. And to start the discussion on this topic and to, let's say, understand the story of the identity model along the year, I would like to present you, first of all, three different models. The first one, let's say the oldest one, is the classical siloed or centralized identity model, in which you essentially have an account to an organization, you have a username, you have a password, but this kind of identity is not persistent. Why? Essentially because if you delete your account or the organization simply delete your account, you don't exist anymore. Essentially, this model does not fit with our objective. Why? Essentially because you exist only in that organization. You cannot reuse your identity anywhere else. And of course, this comes with several troubles because you have to store and maintain a lot of username and passwords, and you essentially don't have let's say today we have several key management system, but you have essentially to remember which account you have in each organization and whatever and what else. Essentially, you cannot reuse this kind of identity anywhere else. Of course, the community made several steps ahead, and the second model of identity is what is called third-party federated identity. Essentially, you have an account, again, you have an account with an IDP, identity provider, and then you can log in with your account in all the organization covered by that EDP. The classical example is the login with Apple, login with Facebook, login with any other EDP that you know. Of course, these helped a lot in simplifying the identity model, how we use this identity, but doesn't solve, again, one of the needs that we set at the beginning. Because for sure, with a single account, you can log in several organizations, but you have to remember which one for each organization. And again, this identity is not persistent on the internet, because outside of that federated system, you don't essentially you don't exist. Is not lifelong, because again, you can delete, you can lose your account, the EDP can delete your account. So this was a very nice step forward, but it's not the solution that we are looking for. Not only both the model provide you a username and a password, and these two information doesn't really describe you as a person, or you as an organization, or you as an object with details. No? So it's simply username and password. The third model, and this is our first step in the self-sovereign identity model, is a completely new and emerging model that starts from the classical peer-to-peer approach. We here don't talk about organization, username, password, whatever, but we are interested in establish interaction between me as a person, as an organization, or as an object with a peer, someone else. This means that with this model, we want, and we also are able to interact with anyone else. If the other peer is a system, if the other peer is a person, or if the other peer is an organization. We want to essentially make this trusted interaction between peers. And what make this model viable is for sure a distributed ledger technology. You know, I think you know many of them. We will address some of them in this module, but essentially an immutable storage of identity information that we can use to establish, from the cryptographic point of view, this trusted connection between peers. What is very important also in this model is that peers have their own digital wallet. Okay? Forget about password or password manager. You have your own wallet on PC, on a laptop, an embedded wallet within an IoT device. And this digital wallet is the interface that lets you essentially interact with your peer when this peer is someone that can provide us credential to get this credential, store this credential, and in other case, to present our credential for authentication purpose, for example, or to prove our identity to our peer. Essentially, we have a completely new model in which we can describe with one or more credential really who we are. We will see with the data model available that we can describe in details our identity, and the properties of our identity will be also useful for not only for authentication, but also for authorization to resources. And we can combine this credential to create, let's say, an interesting identity that describes in details who we are. Not only this model won't and let us reuse this credential with anyone else. So lifelong in the sense that if you maintain your secret with the best practice cybersecurity practices, essentially you can maintain your identity forever. Of course, we will see all the procedure to rotate the secret, rotate the keys, but essentially you have your credential that describe you and your identity for your entire life, and you can reuse those identity with any system or with any other person. So we reach the needs that we set at the beginning, because essentially no one can delete our identity. We can reuse it. So this is what we are going to address, and this is the kind of models behind the self-sovereign identity. Now, this is a decentralized identity model. What does it mean, decentralized? Just to understand the meaning of the words. When you talk about, for example, a distributed system is a system that is distributed geographically and can perform one single task. You can divide, for example, your single task in the different subsystems. They work together to reach a result. When you think about decentralized system, you have to think about essentially to taking decision. So in a decentralized system, the important point is who takes decision. And again, in a decentralized system, we want anyone autonomously to take their own decisions. The behavior of the whole system is the composition of the different decisions. But when we say this is a model of decentralized identity, is essentially that anyone, an organization, a person, or an object can take his own decision about generating its own identity, generate the proof to prove their identity without a central authority. Essentially, we will use several terms. Here, I use the term subject to say anyone, okay? Have full control over the data they use to create and to prove their identity. No one have the authority to give our full identity, to revoke our identity. So this, as said before, for the fact that we have essentially a very simple peer-to-peer approach, and thanks to the existing standards and recommendation, this model opened the way for interoperable authentication between anyone, people, system, and objects. I can use my credential to access the Polito website. I can use it to have a direct trusted interaction with a person. I can use it to open my car, to start the engine, or to any other information system I want to access to. This is really an emerging model. We started, I heard about, the first time I heard about self-sovereign identity was 6 years ago. Exactly the time I saw a video describing the three models. That was essentially the first information that introduced me to this topic, and is not fully consolidated at the moment, is not fully standardized. There are recommendations, but the whole identity community is really working hard today on evolving this model. So the specifications are there. We will address some of them, but are evolving. So will be possible that we start today talking about a version of a recommendation, and maybe by the end of the course some point will change. Don't worry about it. What I would like to introduce you and to present you are essentially the core principles of the model, but knows, in particular, if you will like this topic and you will do research or developing activities on this, that day by day things change. Is for sure a hot topic in the identity community. There are several organizations that are working in developing the standards, developing the technology, and in deploying some of the preliminary services over the internet. So there are rooms for ideas, rooms for developments, and for deployments. If you really will like this topic, there is a lot of work that you can do to participate and to contribute to this. Why I say that? Essentially because normally in university lessons, the professor presents you very well-established solution, very well-established architecture, protocols, and whatever. SSI is, in my opinion, something really interesting, but will change over the year. Now, let me start from a small recap of what a centralized system for identity of how it works. And I suppose that at the beginning of this course, you addressed the PKI, right? Good. So just this very simple figure to remember the working principles of PKI. That is the classical centralized identity system, because everything works around a certification authority. So you, as a subject, essentially generate your key pair. You protect the private key in a protected storage, and you use the public key and the subject ID to generate a certificate signing request with all the details. You submit this request to the certificate authority that, after the right check, the common checks and the common verification procedure, issue to you an X509 certificates. The certification authority also deal with the revocation of the certificates, no? With the OCSP or with the CRL. So the certification authority is in the middle of the process in any step of generating your identity and in the authentication procedure, also when the verifier check for the status of the certificate itself. Also, what about if you want to rotate your keys? So you generate a new key pair. Essentially, you have to refresh the certificates. So this is the classical centralized system for identity. Now, this is the whole framework of the SSI. Why I presented you now? Essentially because I want to do this sort of exercise. I will present you now the whole framework, all the working principles, okay? I don't expect that you understand everything now, but I want to give you the big picture of this framework. And at the end of the course, after all the several lessons in which we address in deep details all the single layer of this framework, I hope that at the end, when we will do again these exercises of presenting the system, you will have the whole picture and you understand all the details behind this framework. Okay, so let's start from the bottom. Layer 1, verifiable data registry. Here I used this generic term, verifiable data registry. We will see that verifiable data registry can be central classical trusted databases or DLTs. Can be a blockchain, can be a Tango, any DLT that are out there ready to be used on the internet. And the very good news about this framework is that the whole framework is completely independent on the VDR of choice. You can build your own framework and solution on the VDR that you select. Can be a DLT, and we will see during the course, for example, the identity solution provided by the IOTA Foundation that developed is a framework on top of their DLT, the Tango. We will see other approaches based that use the classical web infrastructure. And in some cases, we will see solution that doesn't use VDR. In particular, some solution that use static keys for building the whole identity. Every single peer in this framework use what is called a DID method, a method, essentially a software logic that is, yes, in this case, VDR specific, that essentially provide you the primitives to interact with your VDR. I said at the beginning that the framework is VDR independent. This means that two different peers that want to enter in a trusted interaction can also use different VDR. The important things is that if peer A want to interact with peer B use a particular DID method and a VDR B, the peer must implement not only his own method to interact with this VDR, but also the VDR of the peer. Why? and we here arrive at layer 2, the other key components of the self-sovereign identity framework are the DIDs. DIDs stand for decentralized identifier. At this point of the course, you can think about a DID like a URI that essentially provide you the address of the public key of the peer on the ledger. Essentially, before interacting with the other peer, every one of us store our public keys in what is called DID document within the VDR of choice. At this point, this first, very first and only first interaction means I want you to prove me that you own the private key behind your public key that you presented me by giving me your DID. Essentially, you at the beginning give me the address on the VDR where I can find your public key, and with the classical challenge and response protocol, I want you to prove that you own the private key. So if we look at the right, layer 1 essentially will store public keys. At layer 2, we generate our DID, that is the pointer to our public key on the VDR of choice. So at layer 2 of this framework, our self-sovereign identity is the composition of a key pair and a DID. Again, completely decentralized until now, completely decentralized. No one govern a DLT, essentially. We generate the key pair, we generate our DID. I can choose the VDR I want to use for storing my public key. So I choose the implementation of the software logic that help me interacting, essentially writing and reading from the VDR. If I want to enter in interaction with others, I have to implement a set of this DID method. What at this level is not, let's say, is still not achieved is that lifelong, because DIDs stand more or less forever. Of course, I can simply, and very simply at this point, with respect to PKI, rotate my keys, because I can simply generate a new key pair. And at this point, I have only to update my public key on the ledger. My DID remain valid, and at this point, I do not enter in interaction with any authority, because until now, everything has been generated by me. Also rotation, no? We saw what happened, if, for example, in PKI. If I want to rotate the keys, I have to re-enter interaction with the authority. The authority is not involved at all until now. And we are layer per layer, building our identity. Now, at layer 2, we have a key pair and a DID. With respect to the needs that we defined at the beginning, we didn't achieve one more things. I want a rich full description of the identity. And this can be achieved with the layer 3 and the use of credential. Credential are essentially a new type of credential, absolutely equal to the physical credential that you have in your wallet, in your physical wallets, that I can use in conjunction with my decentralized identifier to prove my identity to another peer. At the layer 3, we deal with the classical triangle of trust. The triangle of trust is made by one or more issuer of credentials, the holder. Essentially, the holder is the person, the object, or the organization that hold the credential, and the verifier, someone else, my peer, that verify my identity. We will work a lot on this layer. We will address the data model of the verifiable credential, how a credential become a verifiable credential, essentially thanks to the digital signature of the issuer, and the verification process. Essentially, anyone in the framework generate his own DID, his own key pair, ask an issuer to issue the verifiable credential, and present the verifiable credential to the verifier. Triangle of trust means that all three trust each other, but trust must be, let's say, built and verified through cryptographic proofs. The only, let's say, not cryptographic trust is between verifier and issuer. In fact, this is called implicit trust. What does it mean? That if I trust an issuer, if me as a verifier trust an issuer, I don't enter in interaction with the issuer when I want to verify the verifiable credential presented by an holder. We will also address how a verifiable credential become a verifiable presentation, essentially a wrap signed by me, by the holder, to present a verifiable credential that describe my identity signed by the issuer. How layer 2 and 3 works together, we will see that the verifiable credential will contain, after the right challenge and response protocol, the DID of the holder, and this DID, together with other properties of your identity, are signed by the issuer. such that when I present my verifiable credential, the first things that you do to verify essentially is to you verify the authenticity of the signature, but then you take my DID, you go to the VDR of choice, the one I decide to use, you retrieve my public keys, and then you can go on with the verification, with all the verification, and we will address them all in details to verify the verifiable credential, and so let me authenticate or not. So, and this is very, very important, something that you have to take in mind every single time you want to study or do activities on self-sovereign identity. With verifiable credential at layer 3, you essentially have all the components of your identity. And all the components of your identity are a key pair, public and private keys, your DID. We will see that public keys are stored in the VDR within what is called DID documents, simple JSON files. So DID document and at least one verifiable credential. You can hold more verifiable credential, more than one, but these are the components of your self-sovereign identity. If you don't have all three, you essentially don't have an identity. On top of these three layers, any single subject, objects, people, information systems, whatever, can generate their own self-sovereign, means their own identity, and enter in trusted interaction with anyone else. Okay, I'm pretty sure that some concepts are clear to you, other no. This is not a problem. This is just the first lesson. At the end, we will recap again with this slide the whole framework. At that point, I really hope that everything will be super clear, that the working principle of all the layers will be understood, and you have a complete control of the whole framework. Now, just to avoid any confusion, along this module will essentially deal with authentication and authorization. I just want to be sure that you have clear the difference between the two. No? So authentication is the act of proving a claim, in our case, the identity, and the process of verifying that identity. Authorization is the act of determining that an authenticated subject can or cannot access a given resource. Essentially, authorization depends on authentication, because you first authenticate and then check for your identity properties to understand if you can access or not specific resources. Okay, so now let's start our journey, building block per building block, interaction and protocols and algorithms, step by step in all the layer of the framework. Okay. The VDR essentially are systems that store, and of course I'm doing this, let's say, definition in the context of an identity framework. In other contexts, maybe you can have different descriptions, but that's more or less a good definition in this particular topic. So a system that store and manage public keys, credential schemas. I didn't already introduce this point, but when a verifier start verifying a verifiable credential, he knows the issuer of that credential, and to validate it, need to know the schema of the credential. This is why the issuer also store in the VDR these schemas: revocation information. Any identity systems to be really deployable and usable must also address revocation, because if you cannot revoke your identity, essentially your solution is useless. So also in the VDR, the revocation information produced by the issuer of the verifiable credential are stored, and all these information are used to verify the authenticity and the status of verifiable credentials and DIDs. Can be implemented with various technology. Distributed ledger technology are, at least in the most of the community, the most appropriate for that, essentially because a DLT, a blockchain, or a Tangle, or any other technology provide you immutability and persistence of the information, so no anyone can tamper with those information. But we will see solutions based, for example, on the classical web infrastructure. DLT are, as I told you, the most appropriate, essentially because at that point, the VDR is considered the root of trust for public identity information. If we want to simplify, public keys, revocation information, and credential schemas. What are the functions of this VDR? Essentially, store identity data and metadata. We will address several data models that use not only data, but also some metadata. Immutability and permanent storage are, in my opinion, the most important features, because let's think, for example, to the case in which we use a VDR that doesn't provide immutability, but we need immutability because no one else must change our public keys. We have to deploy extra system features to check, for example, for any authorized or not authorized change of information on the VDR. On the contrary, if we have a DLT and we believe in the immutability of the technology, we don't have to take care of controlling the status and the integrity of the data that are stored there. For sure, support DID resolution. This is the first time you hear the term resolution. DIDs, the centralized identifier, essentially URI to your public key on a ledger, are resolved. So someone else, your peer, use this DID to interact with the VDR and retrieve your public key. And of course, support revocation. And we will see in details how revocation is implemented in this framework. Okay. Resume recording. Okay, now let's talk about the decentralized identifiers. We are at essentially at layer 2 of the framework. And roughly speaking, DIDs, the centralized identifier, are essentially the URI that let you inform someone else of where to access your public key. The centralized identifier are, with respect to, let's say, existing centralized solution, new type of identifier that are the core and enable decentralized identity model. Let's define two more roles in terms of that a person, an object, or an organization can play. You are essentially a subject, the subject of the identity, but you can also be the controller of the DID. The controller of the DID is the entity that can store, change, update, essentially the public key on the VDR. Typically, the subject and the controller coincide, but there are also some cases in which are different entities. In some cases, you can also have a group of controllers that, when reach consensus, decide to update the public keys. So the DID are designed to enable the controller of a DID to prove control over it without, as told before, the permission or the interaction with any authority. Are essentially URI that associate a DID subject with a DID document to enable trusted interactions. This is a DID. This string. We have three components. First, the DID URI scheme identifier, the string DID, colon, then the method name, that is the name of the method that you have implemented to interact with the VDR. Let's do an example. You want to use a blockchain? Good. You want to use Bitcoin network? Good. The DID will be DID colon BTC colon. Essentially, with the first two information, you are identifying the DID and the name of the DID method that you or your peer must implement to interact with the VDR, where the your public key is stored. And then there is the DID method specific identifier. Essentially the address on that VDR where I can retrieve your public key. Just for you to know, this is the list of all DID methods that has been specified and implemented. Let me say too many. We will for sure address DID IOTA, DID web, and DID key. If you click on this, of course, oops. You click, you go directly to the specification. Okay. So, DID, three informations, three strings with a colon in the middle. DID, method name, and the specific ID, the address, essentially. So, since the DLT, for example, or other web infrastructure-based solution have different addresses, you will see a plethora of DID with essentially various names and format in terms of method-specific ID. Now, what is a DID document? A DID document are stored in the VDR. A DID resolve to a DID document that contain the information associated with the DID. Essentially, a DID document is a JSON file in which we will see all the different properties, but essentially where you store, you write your public key in the document and then store this document on the VDR. So just for you to remember, we are in the middle between layer one, layer one and layer two. You have created your key pair. You generate your DID. You generate a DID document. You write your public key into the DID document and store the DID document on the ledger. How? Using your DID method, your software implementation of essentially the API to interact with the VDR. Now let's see the data model of this DID document. First of all, the DID document defines the context. Essentially, the language, the vocabulary that the peers that want to interact knows to understand each other. The ID of the document, of your ID, that is essentially your DID. So in the DID document, you store also your DID, and what is called the verification method. When you think about a verification method, essentially verification method equal public keys with some more property. For example, again, the identifier of this verification method is important because we can have also different verification method for different purposes in a single document. So you can store more public keys on the VDR through the DID document. The type, in this example, a JSON web key that I suppose you already covered in other courses, but something that you can easily, the specification of the JSON web key is essentially how you express your public keys. You can find everywhere on internet. The controller, so who is the entity that control this DID and have the authorization to store and update this public key, and then of course, in this case, JWK keys, so the encoded keys, the encoded public key. Super simple. So, what are the design goals? So, the goals, the needs, the requirements that the people that define these DID put there at the beginning to drive the design of this technology. For sure, decentralization. So with DIDs are in place for all of us to interact with any other peer without the need of a central authority. Control. That means that everybody that wants to generate his own identity must be able to control his own DID. So give the power to the controller to control the updates of the public key. Privacy, until this, let's say, this layer, there are no any personal information, so are designed for privacy. On this, we can also, but we will see next slide, but I can anticipate. The IDs are essentially pseudonyms, no? So when I enter, I authenticate to a system with the ID, the other party essentially doesn't know nothing else that my DID is, no, and my public key. The point is that when you think about and you talk about privacy, you also have to consider linkability. Linkability are essentially two, let's say, systems that collude, that exchange information behind the hood. And if I use the same DID to authenticate on a system and the same DID to authenticate to another one, if they exchange information, essentially they don't know who am I, but they knows that I authenticate for some services there and in the other system. So if they collude, they can link me. This is called linkability, no? Linkability feature. And DID are linkable unless you implement the use of DIDs using what is called pairwise DID. I mean, I use a DID with a system, I will never reuse with another system. In this point, with this approach, with this very simple solution, even if the two systems collude, they can't link you and understand what are, for example, your preferences when you authenticate and use the services of two different systems. The other goal is security. So to provide the minimum level of security to let anyone else to rely on the store DID documents. The other design goal is proof-based. This is super important. And all the protocols and algorithms for generation and verification of identity will be based on proof, cryptographic proofs. That's very, very important to deal with a trustless system. Discoverability, essentially to make DID discoverable, to start the trusted interaction with the peer. And the other key design goal is interoperability. Since there are, you see many VDR possible for that can be used, many methods and DIDs, one of the design goals is interoperability. So even if we use different DIDs, we must understand each other. And the key to reach interoperability are open standards. Portability. If you think about the description of the entire framework we made at the beginning, essentially the DID method is the point on top of which the whole framework is completely independent on the VDR of choice. This means that with few changes, I can port my identity to another VDR for any reason, because I don't trust anymore that DLT, because I just want to change, whatever. Okay? So essentially, the DID are completely independent. Not the DID. The framework is completely independent on the VDR. Simplicity. We will see that the standards define a simple set of features to make DID and DID document easy to be implemented. The specification is quite simple. And where possible, extensibility. This is a design goal not only for DIDs, but also we will see for verifiable credential. Everywhere possible, the data model, the standard defined data model give us the possibility to extend properties and information that we want to store. Of course, we have to take care of security and privacy when we decide to extend the data model. Okay, now let's see the whole DID architecture. Again, at the core of the DID architecture, this is the verifiable data registry. DID are the strings that we use to let someone else know where our public key is stored, resolve to a DID documents. So if I resolve the DID that you provide me, I retrieve from the VDR a DID document that contain your public key. So saying that DID and DID document are recorded on the verifiable data registry. DID URL, of course, contains DID and refer to DID document. DID also refer to a DID subject. As I told you before, there is one more row that is called DID controller. Very often, DID subject and DID controller coincides, but the specification let us define as to them as two different entities, even if, let's say, in real implementation, I've never seen them, but it's possible. Now, let's see the properties and the description of the properties that we can add to a DID document. Essentially, the identifier of the subject, the DID. Why the DID is so important in a DID document? Essentially because I want to double check when I resolve a DID that the document that is returned refer to the DID. So I want to see the DID also in the document when the VDR give me back, the resolve give me back the document. The controller, that is again the identifier of the controller, essentially the entity that can make changes to the DID document. Another important properties is also known as this property let you define a more, let's say, human readable description of the subject. And the service property. The service property is any type of service that the controller want to promote to enable interaction with it. So when I give you my DID, I give you this DID not only to let you know where you can retrieve my public keys, but also I want to say you, if you want to enter interaction with me with a specific service, this is the URL that you must contact. Okay? And I can promote several services. If you want to authenticate with me, contact me at this URL. You want to message me, contact me at this URL. You can essentially promote all the services that you want to add using this property in the DID document. Then the verification method. Maybe the most important verification method are essentially the public keys, which can be used to verify proof. You know, since from last year, when you start the lessons on cybersecurity, that a best practice is to use different keys for different purposes, no? So the DID document let us define general verification method, or using what are called verification relationships to define specifically the use of some method for a specific purpose. So the verification relationship are essentially authentication. So you can use this public key when you want to enter in contact with me, authenticate with me. Assertion method. These keys are typically in the ID document of issuer, because it's the issuer that assert claim about our identity. So when we will see when we will address verifiable credential, when I want to retrieve the public key of the issuer to verify the proof on the credential, essentially I will refer to which public keys, if the issuer have more than one, typically the one for the purpose of assertion. And key agreement. These are the three defined by the specification. Essentially, verification relationships are expression that one or more verification methods are authorized to verify proof made on behalf of the subject. Essentially, let us associate the verification methods, public key, to be used for different purposes, and only for that purpose. I don't want you to use an assertion, a key that I use for assertion for authentication. So, if I use the property authentication, essentially I'm publishing the public key to be used during the authentication process. An assertion method, the public keys, an issuer of verifiable credential use when asserting a claim. So during the verification process, I will use this key when I want to, for example, verify the proof made by an issuer, or key agreement, the public key to be used during a key agreement protocol. For example, um, the key used to encrypt a symmetric key. Also, the verification method itself make use of specified properties. So remember let's see, just for you. Okay. We saw some properties that are outside the verification methods, no? That you can put in a DID document. And now let's see the properties that you can use within one verification method. Again, identifier, that is the identifier of the subject, the controller, the type of verification method, the kind of public key, essentially of the encoding that I've used. Normally, there are two options: public key multi-base and public key JVK. JVK were used a lot 2-3 years ago. Now the community is moving to multi-key and multi-base encoding. We will see multi-base in the next part of the course. So I don't think you will find a lot of public key JVK anymore in real DID document, but anyway, the specification let you use it. Then revoke, the property revoke, essentially the date of the revocation of that specific public key and the property expire. So you can also define and publish on the VDR a date when the public key will expire. For what concern the service properties, so again, within a DID document, you can also define a service, and you can use this property to promote and inform your peer of the URL where he can contact you for the service. And the property service have some other sub-properties. Again, ID, in this case, this is an identifier of the service, the type, essentially which kind of service are you promoting, and the service endpoint, the URL to contact to use that service. Now, if we recap a bit all these, essentially the data model and all the properties that we can use in a DID document, essentially those properties are statement of the DID controller that in many cases coincide with the DID subject, that describe essentially how to interpret the representation of the DID document, context, essentially. Identifier of the DID subject, the ID, this typically the DID of the subject, and how to interact with the DID subject, verification method, public key, and the service. Okay. Now I would like to do some exercise with you on the ID document. But if you have any question on the ID and the ID document, this is the right moment to ask. Okay. Let's reuse some of the properties for doing the exercise. So the first one, I would like you to, I give you some minutes to think about it, and then we can solve all together the exercise. So the first one is very simple. So let's write a DAD document that use two verification method. So a simple document in which we want to publish two public keys without specifying um, the purpose for these two verification methods. So just take some minutes to understand how you can do it, and then we can solve it together. Okay, so let's us reuse some of the properties of this very simple DAD document. So we need to define a document with the, for sure, the context. In this particular case, we are referring to the W3C specification version 1.1, and that you will find also in the reference slide that specify the DID. Then the DID of the subject. We can at this point in time simply use this example DID using method name and method specific ID, and then we said two verification method. So here is very simple, because if we want to add a new one, we can use the same verification method, and instead of defining a single method, we can define a vectors of method, and so in this way, in a single document, we can define two methods. Now, we will enter in details in the next lessons, but let's do the exercise not using the JSON web key, but multi-key. So we can, in some cases, use the multi-key type, and of course, the public key, the encoded public key, we use the property public key multi-base, and then the encoded key. Let's expand a bit in case of JSON web key to see which are the, how we can, for example, define a public key in JW key format. So in this case, I think you already addressed these in many other courses, but to define a JSON a JWK, you essentially use the property key ID. For example, key 34, the identifier, the unique identifier of this key. Then you use the property KTY, it is the family, essentially the family of crypto algorithms that you use, that you want to use, that you use for generating the key pair, and also for signature. So let's do, in this example, the classical example of elliptic curve. Then in this specific case, you have to define the curve, the specific curve that you used. CRV. Let's, for example, use P256. Now you specify, you have the global family of algorithms, the curve, the specific curve, and then you have to specify the specific algorithm. That you have used to generate and to generate the keys and to sign. In particular, let's, for example, use ES256, that is a particular specific algorithms that use SC on the curve P256 with SHA-256. Okay? Yeah, please. It's new. If you want to specify here the same, the true DIDs on the same PDR, so using the same method, you can do it. If you want to use different, if you want to specify, let's say, the data model can let you also specify DID that refer to others. The point is that normally you don't do that because when you resolve on that VDR. So let's say you can do it in terms of data model, but it's useless. What is important is the use here in ID property, the use of fragment. Sometimes, very often, I can use for example, the fragment key1 to refer to the first key in the verification method and key2 to refer to the second public key. Now, exercise number 2, write a DID document with 2 verification methods for 2 specific purposes, assertion and authentication. So you can see here the results to the first exercise. You can use it as a reference to think about few minutes on how to solve the second one. Okay. Let's see how we can solve Also the second exercise, context and ID. We can reuse the same. So now the exercise asks us to use to provide true verification method for assertion and authentication. So let's do this way, for example. Authentication, the property authentication, and then I can add all the sub-properties for the authentication one. So essentially, the ID, let's use also the fragment. Then type. In this example, let's use multi-key. Then I have to specify the controller of this method. Let's do, in this example, in this solution, go for the case in which controller and the ID subject are the same. So I use the same DID specified at the beginning. And then public key multibase that contain the encoded public key. Now, the first is done. The exercise asks us to specify also a public key for assertion. So this can be the simplest DID document of an issuer. So we use the property assertion method. The ID, in this case, key 2. And that's it. Okay? Comma. And closed. Okay? Okay, let's go on with the exercises. Number 3, generate the document with 2 verification methods for assertion and authentication purposes using fragments and references. So let's see with this exercise how we can use references in the edit document. We can use reuse, for example, this one. Okay, two DID, 2 verification methods. So we can sure reuse this one, generic, but the exercise asks for specific purposes of authentication and assertion. So you see that we defined 2 generic verification method. Now I want to specify which one for authentication, which one for assertion using references. So very simple. I use the fragment. Authentication, for authentication, you can use key 1. For let me make it a bit bigger. For assertion method, for example, key 2. So essentially, this notation is equivalent to writing the whole DID with a fragment. Okay? Any question on this? Clear? Good. Now, Exercise number 4. Add the document with one verification method for authentication and promote a service. So let's do an exercise using the service property. So just essentially, I can reuse this DID document that provide one verification method, public key multi-base encoded for a public key. I have to specify the service property. The subproperty of service are ID, type, and service endpoint. So let's use them. ID, in this case, is the identifier of the service. I can specify using the DID and using a specific fragment. For example, let's do an exercise in which I promote a messaging service. So I can use, for example, this fragment. Then type. Type can be whatever you want. So, for example, messaging service. And then the property service endpoint. What do you like? Okay. Of course, I can also promote different services. In this case, made a vector of services. I can promote the number I want. Okay. any service I want. Any question? Everything is clear? Essentially, you have to read again the different properties. We know that from the general point of view, we have to provide a context, essentially to define the vocabularies that we all know to interact. ID, the most important, because it's essentially my DID. And then verification method can be generic or specific, authentication, assertion method, key agreement, and optional if you want services. If you don't, for example, provide this information on services in the DID document, means that the application that use your identity that let you interact with someone else must provide this information. So it's up to you to decide, it's up to the DID method specification and implementation to decide what you want to insert in the DID document and what you want to publish on the VDR to give information to your peer. Okay? Good. Now, let's move now to, so we address DID, let's move now to DID method. DID method are essentially the building block in the whole framework that let you interact, let you peer, let you subject interact with your VDR to generate your DID and to store the DID document on the VDR. And is also the main building block that make the whole framework VDR independent. Different peers that use different VDR can enter in trust relationship. One of the requirements is that both have to implement the same DID methods. Because, just to recap, me and another peer, we want to enter in relationship, I give him my DID, I receive back his DID, I have to resolve his DID from the ledger to retrieve his public key. The peer do exactly the same. So we can do it on the same VDR or on different VDR. But if we use the same or we use different VDR, we peer both have to implement the same specification of the DID methods. Okay? So the DID methods are really associated with a particular VDR. Is the software logic that let you interact with the VDR to handle DID and DID documents, and its specification define what is called CRUD, or that are the mechanism to create, resolve, update, and delete DID and DID documents. If we use a DLT that provides us immutability and persistence, of course, delete is impossible. So in this case, we refer to deactivate. Okay? What does it mean? That since I cannot delete anything from a DLT unless the DLT does not provide persistence, that means after a certain period of time, the data are pruned. Just to give you some example, the iota tangle works like this. So after a certain period of time, unless you ask for permanent storage, the transaction that store data and anchor data to the DLT are deleted. So unless this feature is available, you cannot delete anything, and so you deactivate. That means you have to store on the ledger a proof that the DID has been deactivated. Because during the resolution of the DID, I must know that the DID has been deactivated or revoked. The different implementation discuss beside the CRUD operations also security and privacy consideration that are consideration that any implementers, any developer of the specification must take into consideration not to break security and privacy feature of this specific DID method. Oh, okay. Not only a DID methods must specify the authorization procedure to execute CRUD operation, including any necessary cryptographic process. That means how a DID controller create a DID and associate a DID document to that DID, of course, is the VDR specific. Because just to give you an example, if you use the web infrastructure, you define the address and then you can write on that address. But if you do it on a DLT, sometimes we have to make a transaction to store a document and then you receive back the ID of the transaction that is normally used as a specific ID in the DID. So any VDR has its own peculiarity, and any specification of DID method specify exactly how to do the different operations. How the DID resolver use a DID to resolve to a DID document. DID resolver is the entity that resolve a DID. So someone that receive a DID and is able to interact with the VDR to retrieve back the DID document and so the public key. Specify how a DID controller can update its DID document and what kind of updates are possible. In some specific implementation, specification, sorry, or implementation, it's better. You can overwrite existing DID document. In other, you create a chain. So it's depends. And that's also very important how a DID controller can deactivate permanently or temporarily a DID. Just to avoid any confusion, CRUD, create, read or resolve, update, delete or deactivate, refer to both DID and DID document. Because DID and DID document are two different technology that we use to build our own identity. Okay? So I can maintain a DID, but update the DID document, or I can completely deactivate a DID, and so the DID document, and generate a new one as an update. But I decided to change the DID. So both options are possible. Now, let's go through DID resolution. And I think this can be the last topic for today. DID resolution means retrieve a DID document from the VDR given a DID. Refer to R in the CRUD operation. It differs from DID method to DID method, of course, because any VDR provide you different mechanism to read data store in their distributed ledger. The software logic or hardware component able to resolve a DID is called a DID resolver. Let's see the function. This is a general function. Then any DID method specify its own, but following these templates. Essentially, resolve require a DID and some resolution options. Provide you back DID resolution metadata, the DID document itself, and DID document metadata. As I told you at the beginning, the VDR does not simply store documents, but also some metadata that are very useful in particular in resolving the DID. DID, let's see the properties. DID is the DID to be resolved. Resolution options is a structure of metadata that we then see in details to provide options to consider during the resolve operation. So the resolver will consider this metadata in the resolution of the DID. We receive back the DID resolution metadata, a structure with the value resulting from the DID resolution process. Essentially, this metadata describe in some way the resolution process, the DID document itself, the JSON file that we now know very well, and the DID document metadata. If the resolution is successful, this is a structure with the metadata of the DID document in the DID document property. Okay. Let's go through the options. The property accept essentially lets you define the media type preferred representation of the DID document. Expand relative URLs is a Boolean flag to instruct the DID resolver to expand relative DID URL in the document to absolute URL. Sometimes is useful. Consider that, in particular, if you use a DLT, writing on the DLT as a cost. So reducing as much as possible the amount of data that you store, so reduce the size of the document is useful. Then version ID, you can specify the specific version of the DID document to be resolved. This is useful in particular when there are multiple updates and you want a specific version, so you want to resolve a specific version of the documents. Of course, the method and the DLT must support this kind of updates and maintaining the different version of the documents. Some do, others not. Version time, the timestamp of a DID document to be resolved. DID resolution metadata, content type, the media type of the DID document return, and error, simply a data structure for that deal with the different errors that can happen when you read from a DLT to retrieve the DID document. And I think we can close for today. Tomorrow, we will be together for 1.5 hours.